Everyone needs to get love from their homies. That's my homie. Get it?
I
Get
thought
it?
your homie was a bunch of steaks.
Get it?
No.
His name is Mahoney,
Oh my
but I
God.
call him Mahomie.
He didn't say
Do you
that.
get it?
He didn't love you back. So
Mahomie.
It's not your homie.
Mahomie.
You're single.
No, I'm not. I already won the game. So, anyway, all right, for those people actually doing work, let's see you ready. Wait, hold on. I'll wait till you're done. So you don't like fling eggs at me again. We ready?
Yeah.
Okay, all right. Class.
Yes.
Thank you. All right. So, we can't start class without that. It's weird, right? It's weird. Can't, yeah. Anyway. All right, so this is actually an example of going through and looking to see to maximize area. So here is a area with using a 3x3 and like a flexible square play yard, little playpen, or you could just call it like a little thing for dogs and stuff like that.
It's 3 meters tall.
Yeah, meters. Anyway, so right here, a 3x3. So what they did is by removing one of them, so a 3x3 is only going to give me an area of 9 meters squared, but by removing one of the sides and putting it up against a wall, okay, like this, it's 3x6 now, and so that's going to give me an 18 meters squared. So that's just like that problem that we did yesterday with the fence and the river and the farmers and ranch and all whatever that was. Okay, here's another one. A manufacturer needs to produce a cylindrical container with capacity of 1,000 cm cubed. The top and bottom of the container are made of material that costs 5 cents per square centimeter, while the size of the container is made from material costing 3 cents per square centimeter. Find the dimensions that will minimize the company's cost of producing the container. Now, we have a couple things going on. So, let's start with, this is a volume problem, right? Okay, 1,000 cm cubed means it's a volume. And then now, since it's not just going to talk about what is inside of it, but we're also going to talk about the area of the can. So that means I need a surface area formula to go along with that. So I have two formulas that I'm dealing with. One is my volume. So the volume of a cylinder, anyone recall?
Height times higher square.
Yep, that's it. So pi r squared times h. So think of it like this. So pi r squared is a circle, right?
Yeah.
So it's a circle, and now times h makes it a tall circle.
Yes, cylinder.
Yeah, a tall circle.
Tall
So that's the way I think about it. So once we actually get into area formulas for some of this other stuff, it starts with a whatever shape it is, and then just we multiply that times whatever the height is. So we're gonna do some more of that. Anyway, so that's my first formula that I'm trying to do, right? Okay. So on this one right here, I know that this is going to have to equal to 1,000 cm cubed. Okay, good. Now the next thing I need to deal is the size of the can. Okay, size of a can. So I don't have a can here, but
You don't have Monster anymore?
I do, but it's, come on then. Anyway, so here, I'll draw a can for you.
No.
What?
No.
What? It's a country. What country is this? Canada! There we go. Yeah, eh? Yeah. Anyway, so it's a Canada. Anyway, to go along with that, so we're gonna have a couple things. So first, I'm gonna use my colors, and so let's start with the circle. So if we're dealing with the circle part, we're dealing with the area of a circle. And I have two of them, don't I? So the area of a circle is going to be, so my formula is for my surface area. I call it SA. It's normally referred to just SA as a surface area. So I have the area, which is pi r squared. But since I have a top and a bottom, I'm going to multiply that by 2. That's going to take care of my top and my bottom. Yeah?
I
No?
thought you can just take the bottom and just time it by the height.
No, because we're talking about that we're around the outside, just the can.
Oh.
Nothing in the inside, all outside.
Okay, okay.
Okay? So now I'm going to draw, and let's see if we could actually figure this one out. Okay, that is the shape.
Okay.
Now, we got to put in some values here because from that information, what is this value right here going to be? What is just this value?
H.
Very good. That's going to be my H. That's H. And the top right here, is wrapping around the can. This is wrapping around the can. So this is going to be wrapping around the circle on top and bottom, right?
Circumference.
That is circumference, right? So the circumference formula, what's the circumference formula?
2 pi r.
2 pi r. You sure?
Yeah.
Yes, it is. I'm just making sure.
You can't.
You said it with
square-
the question mark.
If you square it, it's going to
Yeah,
be.
hey, you said it with the question mark. That's on you. Okay. So this is going to be my 2 pi r. And that's going to give me, if I multiply 2 pi r times the h, because this is a rectangle, isn't it?
Yes.
Since it's a rectangle, it's length times width, base times height, right?
Yes.
So to get just the surface area here, I need to actually figure out that area, and that's going to be for my total surface area. Two pi r times h. And now I have the whole surface area of the can. Yes?
This one is helpful for my NWA. There's so
Hmm?
many of these questions.
NWA?
They have a lot of optimizing questions for some reason. I was like,
When did we do that?
oh no, when I did the NWA,
NWA?
yeah, they had these for some reason. I was like,
From a long time ago?
yeah.
Oh, yeah. Yeah, we're a little bit behind, so that's why. Anyway, so right here, we now have a surface area formula, and then I need to try to minimize the cost. Okay? Now, so there is a couple things that I need to add to this formula. That is straight up just the surface area formula. Yeah?
Yes.
Okay, so we're going to plug in some values to go with my surface area formula, which is going to be this. The top right here cost me how much? Yep, 5 cents per square centimeter. The side or the lateral area is going to be 3 cents. Okay, so now we have to go through and start plugging in information to go along with this. What am I optimizing here? Okay, I'm optimizing the cost, okay, and the cost is based on is it based on the surface area or is it based on my volume?
Your volume. It says dimension. I'll see your volume.
Nope.
No?
We already know what the volume is going to be.
Oh.
We're just changing the size. So do I want a really tall cylinder or do I want a short, fat cylinder?
Oh, so surface area.
Surface area. So I am optimizing surface area. So let's go back to what we were talking about yesterday. So if I'm optimizing surface area, what do I need to do? Yesterday we learned what?
Make it equal to 0.
What equal to 0?
The derivative.
First derivative, right? I need to put the derivative equal to 0 to optimize it. Now let's start thinking about this. So now if I'm going to minimize it, if I'm minimizing this, what shape do you think this one's going to end up being? Throw up some gang signs.
I feel like it's gonna get.
Which one has a minimum?
Up.
There you go. So it's a parabola up, right? It's gonna look like a parabola up because right there. So that's where we get a minimum. Because if it's a parabola down, that one's gonna give me a maximum. So that's what we're looking for there. So we're looking for something that's gonna look like that. So I'm gonna have it go opening up, okay? And so that's right there is gonna change what I have. So to go along with cost, each one of these, so for my cost analysis, do I have another page here? No, I don't. So for cost, so my cost is going to be my top two circles, right? Which is going to be 2 pi r squared times 0.05. It's my area of my circle, right? Area of my two circles times that, right? That's going to be my cost. Plus my lateral surface area, the sides of the can, which we said was going to be 2 pi r h, and that's going to be times what? 3 cents. Okay? Now, I have too many variables here. What are my variables that I'm using in this problem? What are the variables I'm using?
R.
I have an R, right? I have an R right there. I have an R right there. What else do I have? I have an H, don't I? So since I have too many variables, I need to look at my other formula. I need to look at my other formula so I can isolate and replace one of the variables. And from that other formula, my volume was supposed to be 1,000, right? The volume is 1,000 equal to pi r squared h. Do you agree? Yeah? Just making sure, because it's 1,000 cm cubed, and I have pi r squared h, and my volume was 1,000.
Yes.
Okay, so I'm trying to get this number, my 1,000, into my surface area formula. So I'm going to use this as a substitution. Now, the easiest thing I could do is actually get rid of my h. I can get rid of my h, and I can substitute my h by dividing both sides by pi r squared, pi r squared. So where my h is, I can replace it with this. Okay? So let's go ahead and rewrite this. So this is going to become 2 pi r squared times 0.05 plus 2 pi r. Now I'm replacing this with 1,000 divided by pi r squared times 0.03. Now let's simplify before I do anything crazy like do the derivative. So what's going to happen to my pi's over here? Pi's are going to cancel, right? Okay, pi's cancel. Bam. Bam. What about I have an r and an r squared? I'm going to cancel one of the r's, so the one up here is going to cancel. The one down here stays. So I'm still going to have an r on the bottom. Let's do some multiplication. So if I multiply this number and this number, I get what? 0.6, right?
Yeah.
I get 0.6. Now 0.6 times that 1,000.
600. Wait, 0.6.
0.06, I'm sorry. So it's 0.06. So
60.
So let's see. So it'd be 10, 100,000, right? So it is going to be 60. So I'm going to get 60 for this piece. And then I cancel out everything else. And this is going to be r to negative 1, right?
60.
And I brought the r up, so it's going to make my derivative a little bit easier.
So that's the derivative.
Yeah, it's not the derivative yet.
Oh.
Because right here, the r's in the bottom.
So you moved it up.
Moved it up, so it's going to be easier to take the derivative. Okay? And so I still have that. And now I have 2 times 0.05, which I could clean up, which is going to give me 0.10, right? So 2 nickels gives me a dime, so it's going to be 0.10. Pi r squared. Now let's take the derivative. Okay, so we're going to take the derivative of this. So it's going to be the derivative of the cost, because I made it into a cost formula by adding how much each one cost. So the derivative of the cost in terms of what variable?
dr.
Yes, very good. dr. So this is going to give me
0.20 times pi.
Yep, 20 cents, right?
Okay.
Okay, so it's 20 cents. So it's 0.20 pi r, and this is going to give me a minus what?
Minus 60.
60 r. What's going to happen? Negative 2. Very good. There we go. Yeah? Okay, good. So, we need to set my derivative equal to 0. And then I'm going to factor it also. Is there any common factors I could get out of this? Not really. I could take out 20 cents, which is going to change that one. So divide both by 20 cents. What's that going to be? Is that 1,200?
300? No, that's times.
60 divided by 0.2.
Divided by 0.2 would be 300.
Oh, 300? Wow, I suck at math today. So, it's going to be 0 equals, so if I'm dividing by that, so 0.2 parentheses pi r, this is going to be minus 300 r to negative 2. Actually, let's bring that negative 2 back down to make this a little bit easier. So, because of this, I can get rid of my 0.2, right?
Yeah.
I factor that out to make my math a little bit easier. And let's do a common denominator.
Okay.
So if I factor this out, this goes away, and then the common denominator here is going to be r squared. So that means I need to multiply this side, which is currently 1, by r squared. So I'm going to get pi r cubed minus 300 over r squared. That's going to be equal to 0. And now I can do the math. Okay, this one right here, so the r squared is going to cancel out. R squared is going to cancel out. Then I have pi r cubed minus 300. So let's go ahead and put this in the calculator to see what we get. So we're trying to calculate the radius. When is the radius going to be the minimum for my cost? Who left their calculator there yesterday? Is that you? Okay. Okay, so it was...
Pastor, I'm gonna borrow your voice.
Borrow my what?
I'll borrow this.
Okay, yeah. Okay, where was that? Right here. Okay, so pi r cubed. So what is that going to give me for values? So I can get r cubed by itself now. I can get r, so this will become 0 when I multiply both sides by 0. Then I'm going to add 300 divided by pi, then cube root. Yes, no? So it's going to be 0 equals pi r cubed minus 300. Add 300 to both sides. Pi r cubed divided by pi. And then cube root both sides. So r is equal to the cube root of 300 over pi. Cube root. So right here, control caret is going to give me the cube root symbol. Not really cube root, but just any root. Divided by pi, and use the pi button. So it's going to give me 4.0 4.571. 4.571.
Okay, so rounded to nearest thousands.
Yeah. 4.571. Now, we did this numerically. We got our values. Now let's take a look at what our graph of this is going to be. So I'm going to put the cost function into the grapher to see what the cost function is going to tell me. So we started with 2 pi r squared, so it's x squared, times, there it is. It is 0.05 close plus 2 pi r times, this is where I put my 1,000 in, and over, was it pi r squared? I hope so, because that's what I'm putting in. No?
I'm trying to figure out where you got the 1,000 from, 'cause I lost you. Oh, here it is.
It's the beginning. It's
Yeah.
right here. It's in black. So I'm plugging in this one right here in black because I can't plug in the blue one because I have an R and an H. So after I substitute, I can plug that in.
Oh, okay.
And where am I at now? Times 3 cents?
Yeah, times 3 cents.
Okay. Invalid input. Where is my input invalid? There we go. I didn't put a times. All right, now let's talk about the domain of this since I want to look at my graph, right?
Yeah.
Okay, what values work for this? What can my R be?
Sure.
My R is radius, right?
Yes.
So that means my radius has to be
Not negative.
not negative. So can I start at 0?
Yeah.
I could start at 0, but that's really not going to help me. But for this sake, I will. My R value came out to be 4 point something, right?
Yeah.
So if I take my R to 10, I should be able to see my answer on the window, right?
Yes.
Okay. Now, what values for my volume?
It's like 1,000.
Okay, but it's going to be 0, right? What's my minimum?
Remember it was 0, yes.
So I can't have negative cost. And maximum should be, I don't know, what do we say? The volume comes out to be 1,000. I'm pretty sure that's going to be way too big, but I should be able to see my answer. So yes, it is way too big here. So it goes up way too much here. So I know that there is kind of a low spot right in here.
Is that like the whole gravel?
Yeah, because as it goes up to here, as it gets closer to 0, okay, it's just stretched way too much.
It's just very stretched.
Yeah, super stretched. So let me change the window again, and let's take it to 100. Now we can see it. So there it is. I know it's a minimum, so throwing up the gang sign, I knew that it was going to open up like that. And now we're trying to find right here, somewhere here, where my answer is going to be the low point. What?
I'm used to that being like.
No, it's not going to be a perfect parabola because I have other things here. Like
Yeah.
this x squared in the denominator is going to mess up my perfect parabola. So let's analyze it, and I'm looking for the minimum. So select the lower bound somewhere over here, upper bound right there.
Probably 4.5.
Okay? It's almost like that's the answer we got when we did our math. So does that tell me my math is correct?
Yes.
Yes, it does tell me my math is correct. So, given that value, that's my radius. Now we also have to find the height. So, if that's what I do to find the radius, how would I find the height?
7R.
Put it back in over here in my volume formula. Plug it back in over here for my volume formula. So now, because I know this is my height, I'm going to have 1,000 divided by pi 4.571 close squared is equal to my height. Because all I'm doing is plugging it back into my other formula that I have, that I'm using the height. I have h in my formula. Could I have plugged it back into my cost formula?
Probably.
Yeah, but I don't want to, because that's a mess. I don't want to do that. I have it nice and simple over here. I already have it set up solve for h because h is by itself. And by plugging that in, we said control divide, there we go, control divide 1,000 over pi, parentheses 4 point, what was it? 571. There we go. Close. Enter. So, yeah, 69.637.
You add your unit.
What's my units on this one?
Centimeter.
Centimeters, very good. These are linear units. They are not areas. And by plugging this in all in, let's go back to the calculator, let's go back to the graph, because the graph gave me a y value too, right?
Yeah.
So what does that tell me? What do you think that y value, because I labeled this equation, what did I label this equation as?
The cost.
Very good, cost. So how much does it cost for each one?
$19.69.
Yep, $19.69 is going to be the cost for producing each one of these cylinders with a volume of 1,000 cm3.
So the dimension height is like 69 centimeters. I'm trying to think of that the side right now. Centimeters.
This is 30 centimeters.
Okay, so that's like
This is 30. Okay? So it's going to be pretty tall, isn't it?
okay.
It's
So
going to be tall. It's going to be with a radius of 4, with a radius of 4 point something. So the diameter is probably going to be about 9, right?
okay.
So it is a skinny, tall cylinder that is going to maximize my volume.
And somewhere around $20. Nice.
Yeah. So anyway, that being said, I wanted to stop off here, and there is another problem in our notes right here for this one right here, this one, you are gonna see this one on the homework, okay? I'm gonna save this one for tomorrow.
That's also a free talk too.
Okay, alright, make sure you guys all like, share, and subscribe.